Hello, and welcome back to another episode of Revelations from the Spinning Ball, the place where you can get a little astronomy and a whole lot of flat earth discussion. I am Melissa Fawcett. So, a lot of people are asking me, Melissa, how do you know the earth is round? Well, I know the earth is round by looking at the sky. Now, a lot of flat earthers are going to say, no way, but yes way. God empowered man with the ability to reason, and we can use this ability to indirectly determine the answers to many questions, including the shape of our planet. Our ancient ancestors reasoned out the shape of Earth, and there's no reason that modern humans can't do the same. As you are aware, astronomers watch the sky. They watch how things move across the sky, and they track the motion of heavenly bodies. In fact, astronomers watch the sky so much we know where things don't go. If we make a map of all the visible objects in the sky and put in their relative angles to one another, we end up with a map that contains a dark void in its center, a spherical void. This void represents Earth. So that's how I know the Earth is round. The sky tells me so. So today we are finally going to get to some astronomy because we are going to talk about the sky in general. We're going to talk about the globe sky and the flat earth sky. The flat earth sky is a mess. We rarely get a glimpse of it, and when we do, it always seems to be missing one component or another. I sometimes think flat earthers have grossly underestimated the amount of knowledge that has been obtained regarding the sky. There is a tremendous amount of information. After all, mankind has been watching the sky for thousands and thousands of years, much of this time using only his naked eyes. Flat earthers have yet to contribute anything to modern astronomy, so we're still waiting. Who knows? Perhaps they'll make a workable map, or even better, a functional sky chart. Whatever they do, they need to get on it because as it stands, their sky dome is not in alignment with simple astronomical observations. Let's take a look now at how both the globe model and flat earth model describe the sky. Are you ready? Let's get started. As you probably know already, there are multiple coordinate systems used in astronomy. Let's go over some of these systems now so that you'll be familiar with them. First, there's the horizontal coordinate system. Here, an object in the sky is referenced to the plane of the observer's horizon. This system uses coordinates little a for altitude, or how far up an object is, and capital A for azimuth, or how far around the object is. This system, which works well for setting up your telescope, is problematic when calculating the positions of stars because the Earth is moving. If we want to set the positions of stars, we need some other type of reference frame and one that is independent of Earth's motion. This brings us to the equatorial coordinate system. As the name implies, the coordinates here are referenced to the plane of the Earth's equator. This is perhaps the most commonly used system for astronomical observations. We will return to this system in a later episode. For now, let's just say it uses the first point of Aries, which is a point in the sky, and has the coordinates delta for declination, or how far up, and alpha for right ascension, or how far around. There is also the ecliptic coordinate system. The plane of the Earth's orbit around the Sun is called the ecliptic, and the other planets in our solar system have orbits that are close to this plane. This system uses the ecliptic plane as a reference point with coordinates lambda, which is ecliptic longitude, and beta for ecliptic latitude. As you probably have guessed, this system is used to track objects in our solar system. The last system we are going to mention today is the galactic coordinate system. In this system, the fundamental plane is the plane of our galaxy, the Milky Way, with the fundamental direction being a line connecting our sun to the center of our galaxy. This system uses coordinates L for galactic longitude and B for galactic latitude. This system is typically used to determine the position of a star in the Milky Way galaxy. This is all we are going to cover today because it's more than enough to familiarize you with basic coordinate systems. Of course, astronomers have developed some extremely precise coordinate systems like the International Celestial Reference System, or ICRS. I think it uses the data obtained from radioscopes, but I'm not sure. Anyway, they have spent years and years perfecting this system, which seems like extreme overkill if it's entirely fake or part of some conspiracy. Let's return to the equatorial coordinate system since this is the most commonly used system in practical astronomy. If we make a map of all the major stars visible along the equator over an annual cycle, and we are careful to position these stars based on their relative angles to each other, and we ignore their relative distances from Earth, since distances would only complicate our map, we will end up with something like this. It always looks like this, and it always forms a sphere. We know the sphere represents Earth because all the stars, no matter where they are, never move to any location inside this sphere. There's no trickery, it's simply what we observe. We know it's not a reflection because the stars are not the same on both sides of the sphere. The stars in the northern hemisphere are all different from the stars in the southern hemisphere. It's simply what it is, a bunch of stars with a spinning ball on the inside. If you were paying close attention, you will have noticed I referenced the equator a moment ago. I said, this map represents the annual cycle of stars as seen from the equator. This is true because, as it turns out, only observers along the equator can see all these stars visible from Earth over the course of a year. At my latitude of 30 degrees north, I can see about 300 degrees of these stars. I'm missing the bottom 30 degrees of the planet because I never see that part of the sky from my location. People living at about 50 degrees north or south latitude will see about 260 degrees of sky over the course of a year. If you happen to live directly at the North Pole, you would only see about 180 degrees of the sky over the course of a year. If you want to see how much sky you can see, take your latitude, multiply it by 2, then subtract that result from 360 degrees. Anyway, the stars are always arranged this way, save their precessions over time, and we don't have to travel to South America or Australia to confirm these positions. That's what almanacs are for. Thousands, hundreds of thousands of astronomers, both amateur and professional, verify these locations every day, so of course, we only need to make a phone call to verify any of the data with a fellow astronomer. From our view on the ground, the sky stretches out as far as the eye can see, assuming, of course, that we have an unrestricted view. This spherical pattern of the stars is for convenience, obviously, because the stars are all at different distances from Earth. Even individual stars and constellations are typically nowhere near each other, appearing together only from our perspective here on Earth. Mankind has, once again, reasoned this out by collecting and analyzing spectral data obtained from starlight. The flat ground and dome astronomers use, like the celestial sphere, are purely imaginary and done as a matter of simplification. We depict the observer's point as flat and the sky as a dome because it's the easiest way to present the sky. We sometimes talk as if the sky is moving and not the earth because it's easier to describe things this way. It doesn't mean it's real. No serious astronomer believes this depiction describes reality because it doesn't. So in reality, there's no dome. The spherical void in the center is very real, but reality is more like this, right? From our 360-degree view on the ground, we can measure 180 degrees from north to south and 180 degrees from east to west. The flat Earth dome, the dome some describe as a physical object, is at complete odds with our 360-degree view from the ground. How? Why? Because of perspective. It sort of works along the east to west line of 180 degrees, but only if you aren't too close to the edge. The north to south line of 180 degrees is totally problematic. This is easy to see from my location of 30 degrees north latitude, where I can see 30 degrees on the other side of the North Pole, or negative 30 degrees if you like, down to 60 degrees in the southern hemisphere. This so-called physical dome is at odds with the angles and the horizon. How is the horizon this far up in the sky? And yes, you can say the globe has the same problem, but once again, the globe is a physical spheroid. It's going to look different because it's curved. There's no reason the horizon should be elevated on a flat surface. Now, since I just invoked the P word, that being perspective, let's discuss perspective and how it's used to dismiss the major failures of the flat Earth model. Simply deeming an anomaly as perspective may work on some people, but it's not going to fly with anyone familiar with the sky. We are all familiar with perspective and how flat earthers invoke the law of perspective to explain major discrepancies, so I'm not going to go into detail about it here. But no matter what you do or say about perspective, it cannot and does not change the geospatial configuration of objects in the sky. For example, let's pretend that I'm a very tiny person living under this umbrella, where the middle, the part where the pole attaches at the top, is the North Pole. Let the fabric part of the umbrella represent the sky. If I move away from the North Pole, perspective works like this. Yes, the stars at the top, near our pretend North Pole, will get closer to the horizon as I move away from the pole. They will appear to get closer to the horizon, and they will appear to get closer and closer together. As you can see from this diagram, this is how perspective works, right? Interestingly, this is not what happens in the real world. In the real world, this happens. The stars do get closer to the horizon, but they do not appear to get closer together, not at all. If you claim there's some kind of law of perspective, then this completely violates it. Simple, and I do mean simple observations of the circumpolar stars do not align even with the concept of perspective, let alone any sort of fundamental law, and in fact, align with the Earth being spherical so much that this type of observation is one of the major pieces of evidence for a globe Earth. The flat Earth also struggles with the changing altitude of Polaris, the North Star, as you move to different latitudes. At my location of 30 degrees north latitude, it's 30 degrees above the northern horizon. If we go to 50 degrees north latitude, it's at 50 degrees above the northern horizon. This observation, another simple observation, demonstrates yet another major problem with this type of depiction with or without the so-called dome because it doesn't align with a flat surface. Once again, not at all. In fact, if you include the dome, This depiction only represents one single point on Earth, the North Pole. And even then, we have a major problem because part of the sky is missing. It's gone, a whole 180-degree section. If the dome is included, which it typically is, yet another problem arises because there's the omission of the ecliptic plane. Yes, part of the ecliptic is included in the flat Earth model by having the sun move in and out of the tropics, but the fact that an entire plane exists is ignored completely. I will devote an entire video to the ecliptic later because it's really that important. For now, let me say that the ecliptic plane is both observable and trackable. We move, so it appears to move or kind of wobble every night. It's definitely there and it's very significant. As you will see, Greenwich, England is special for many reasons, and one of those reasons has to do with the ecliptic plane. Then there's the issue with the southern circumpolar stars, which is pretty much a death blow to flat Earth. I'm not entirely sure flat earthers understand how devastating observations in the southern hemisphere are to their claim of a flat Earth. They completely ignore the midnight sun at the South Pole during its summer solstice. Plus, they go one step farther and claim that any footage of the sun never setting as fakery. They have to. The problem for them, however, is that the southern hemisphere sky cannot be ignored entirely because it's right there above our heads. In fact, from my latitude, I can see a full 60 degrees into the southern hemisphere. Even people living in the far north can see some of it. Why? Because the earth is round. For many people, when they take a first glance at the flat Earth, it seems to pretty much align with observations in the North Pole, right? In a ballpark kind of way. The concentric patterns the stars make as they move across the sky become tighter and tighter as we move from the equator towards the North Pole. None of the angles work, however, save Polaris's apparent position above the North Pole, but it fits into the general idea of what we expect to see, right? But when we look towards the southern part of the sky, we see nothing, and I do mean nothing that matches up with simple astronomical observations. In the real world, the pattern of star paths forming tighter and tighter concentric circles not only happens as you get closer to the North Pole, but also occurs as you move south and towards the South Pole. It's pretty much the exact same thing as in the North, just with different stars. There is also another thing that happens on the Earth at both ends. Once you cross both tropic latitudes, moving closer and closer to either pole, the sun will reach a lower point in the sky at its maximum height, but the days will get longer. Think about that. In their respective summer seasons, at each solstice, the sun will reach the zenith along the tropic, then will transit at a lower and lower angle as you move. Yet, in both cases, the days get noticeably longer and longer. So, at both ends of the earth, the sky appears to act the same exact way. Now, if you are unfamiliar with the sky, just be aware that most of us are able to see this phenomenon regarding the concentric circles of stars. You can easily see it in the north if you live in America, Canada, or the United Kingdom. For many of you, the northern circumpolar stars never set. For many latitudes, especially like my 30 degrees north latitude, a portion of the southern sky is also visible. As I mentioned earlier, I can see a full 60 degrees into the southern hemisphere, so much that I'm only missing the circumpolar stars directly around the South Pole. Of course, if you live in places like Australia or New Zealand, the exact opposite is true for you. This depiction does not represent what we observe each night. As you can see, it's not even close. According to this depiction, the stars do not move the same at both ends of the world. According to this, the concentric circles only get larger and larger in the southern direction. All you need to do to show this to yourself is to walk outside and watch the stars for 2 to 3 hours on the next clear night. It's really that simple. As I mentioned in my first video, I have been studying the flat earth for several years now, and in all of these years, I've seen multiple attempts to explain this blatant discrepancy between the northern stars and the southern stars. Flat earthers will juggle things around, use different angles, claim it's an illusion, put the stars in different locations, or even invent personal atmospheric domes. I've even seen flat earthers get very creative with a form of imaginary magnetism. Whatever the excuse, they all layer supposition upon supposition until we have such contortion and confusion we can't tell north from south. Do you know why the star patterns in the south match the patterns in the north? Do you know what the simplest answer is? The globe. Of course it is. Now, earlier I had mentioned something about half the sky being gone from the North Pole. I don't know if you remember that. Now, I want to say something obvious, something you may have noticed already, and something that's going to come to anyone right away that's familiar with the sky. Take a look at the dome for a minute. Now think about how the sun supposedly moves above the flat earth. Think about the day and night cycles, how one half of the earth is always illuminated by the sun, so the other half is always in nighttime or darkness, right? Now go back to the dome. What part gets the night sky? One half. Yes, the flat earth night sky is always a quartosphere. I don't even know if that's a word, or it's 1/4 of the sphere we mapped out in the beginning of this video. In the flat earth, half the sky is completely missing. Let me say this again. In the flat earth model, one half the sky is completely missing. You can't cram all the stars and observed objects, including their relative angles to each other, into a half sky. It's just not possible. As I mentioned a few minutes ago, flat earthers get highly creative when attempting to explain away all the failures and discrepancies we just covered. I'm going to reveal my favorite flat earther now because we are about to look at his explanations for all this confusion. He used to produce a ton of flat earth content, and he was actually once part of the Globebusters. Unfortunately, he's not so active anymore, at least as far as the flat earth is concerned. He's moved on to a lot of other conspiracies, but I'm sure many of you will recognize him. It's the Morgile, or John Christopoulos. Anyway, he once came up with a world-class flat earth mastermind solution. He claimed that the stars are not in the locations they appear to be, but are arranged more like this. There's a major problem with this approach, and it's pretty much my motto, and that is, one man's angle is another man's zenith. One man's angle is another man's zenith. There's no refraction at the zenith, so instead of guessing a star's position, we can call up one of our astronomy buddies and ultimately determine when and where a particular star is directly overhead of someone. Then, of course, we can calculate our angle to it and see if it's correct. Survey says stars are definitely not hanging out as depicted in this brilliant graphic. Sorry, Morgile. I still love you. I've also seen flat earthers try to explain astronomical observations using what they call a personal atmospheric dome. a few years back, a big group of flat earthers got very excited about this so-called personal atmospheric dome, and what they claimed was a completely accurate sky chart software application created by a guy named Walter Bislin. But as it turned out, it was all based upon the heliocentric model because Mr. Bislin was unable to create his program using a flat Earth. He actually said so right in the notes of the program on his website. There's also the Flat Earth Clock app, which I did analyze back in 2019. Now, I haven't looked at it since, but back then it wasn't correct in multiple positions. I'll have to do a quick video on it sometime because who knows, maybe it's improved over the years. Before we finish, let me show you just how bad the flat Earth is at demonstrating star positions in the southern hemisphere. Let's take a quick look at something I did back in June of 2021. Now, this is the winter solstice in the southern hemisphere, and we are all looking at star HIP 112405. Now we're looking from French Polynesia, Chile, and South Africa. Their respective times are 7 p.m., 2 a.m., and 7 a.m. I picked these three locations. I picked this time. This is the same time, okay? This is just their different time in these time zones. But they're all in darkness at this point, okay? This is night sky we're talking about in all three locations. Now you can see their coordinates. We can see the position of the star, and we have their azimuth in each location. In French Polynesia, it's 175 degrees. This is where the star is. In Chile, it's 165 degrees. And in South Africa, it's 184 degrees, okay? 180 degrees is due south, okay, for the azimuth scale. So all three places are looking at the same time, at the same star, and it's in three different locations. This is a clear demonstration of how inconsistent the flat Earth model is with reality. So the bottom line is that the flat Earth system fails when it comes to sky observations. It doesn't map all objects at once, and you cannot describe simultaneous observations for two or more observers on Earth. On the globe, this is done every single day. Now, we will be getting to more of the sky in future episodes, obviously, but for today, let me say that the flat Earth model, according to me at least, is inconsistent with real-world observations. Well, that about wraps up this episode of Revelations from the Spinning Ball. Thank you so much for watching. If you like this type of content, please consider subscribing. And don't miss my next video, which I have no idea what it's going to be about. Probably sun motion or maybe Polaris. We'll just have to see. Until next time, remember, I know the Earth is round because the sky tells me so. Thanks again for watching. We'll see you next time. Goodbye.